Welcome to the Open Source Technology Center. I'm your host, Dan Feinberg, and I'm happy to be joined today by Eric Kaczmarek.
Hi, Dan.
And Soji Denloye.
Hi, Dan.
And of course, by big data, we're talking about information that overwhelms conventional information systems because of its volume, velocity, and variety. And Eric, what do we mean by big data technologies?
So for the past 2 or 3 years, we've been mostly focusing on Hadoop originally, just because it's the very first, most common popular used framework to process and analyze big data. Slowly, in the past year or so, we've been shifting to NoSQL frameworks, Cassandra, HBase, and now most recently we moved into real-time analytics, and that means Storm, Spark, and some other technologies.
And Soji, are you working on similar technologies or a subset of those? What are you working on?
Right now I'm actually working on Cassandra. We're looking into Cassandra to improve performance, which is, in this case, latencies mostly.
Can you draw out the distinction between latency and throughput and why that's important in big data?
So, for example, MapReduce, Hadoop MapReduce, the main performance metric is mostly throughput. In the throughput meaning how fast you can get the job done. But as far as real-time or near real-time systems like Cassandra and HBase, latency is more important. That means you send a read request or write request and you wait for the results to come back to the client. So that round trip from the client to the data store and back to the client, that's the latency. And that really needs to be guaranteed for many applications.
I think that today, in our environment, there's big data everywhere. Your cell phone generates so much data that are constantly fed back to the comms and so on, and they're storing them, they're using them for the various things. People deploy throughout cities various sensors to analyze, when is your light bulb's going to burn off in your street, and when the traffic light's going to change, and so on. So all those data is being fed back to the data centers, and the amount makes it that it's very difficult in the past, that is, to analyze them.
Intel is able to optimize the software and hardware so that they can all work together to improve the performance. Yes, we are a hardware company, but we both are software engineers, and this is the job that we do. We tend to look at these software platforms and try to improve the performance any way that we can.
And Eric, in addition to performance, what other types of enabling work do we do?
As an example, recently Intel has released something called Quick Assist, which allows you to offload compression and decompression. We enable this within Java, within Hadoop. So now you can run your Hadoop workloads and have your CPUs, your core, focus on an analytic work and offload more mundane things like compression and encryption to a, quote-unquote SoC type of device.
Well, thank you, Soji and Eric, for giving us a good understanding of big data technologies generally. For the next 3 chapters in this series, we're going to drill down specifically on Java, Hadoop, and NoSQL data stores.